A Proces turbine is a type of hydroelectric turbine that is used to generate electricity from the flow of water. It is named after its inventor, James B. Francis, who developed the turbine in the mid-19th century. The Francis turbine consists of a spiral casing that houses the runner, which is the rotating part of the turbine. The runner consists of a series of curved blades that are shaped like cups or buckets. Water flows into the turbine through the spiral casing and then enters the runner, where it pushes against the blades, causing the runner to rotate. As the runner rotates, it drives a generator that produces electricity. The amount of electricity produced by the turbine depends on the flow rate and the height difference between the water level above the turbine and the water level below the turbine. The production of a Pelton runner for small hydro requires specialized knowledge and experience in turbine design and manufacture. Here are some steps to consider when producing a small hydro Pelton runner. Impeller design and construction. Impeller design should be done taking into account the specific requirements of the hydroelectric power plant, such as the amount of water flow and the available pressure. There are various software programs for creating 3D models that can be helpful in designing the impeller. Material selection. The Pelton impeller can be made of different materials, such as stainless steel, aluminum, or titanium. The choice of material depends on various factors, such as the size of the impeller and the specific application. Impeller manufacturing. Impeller manufacturing is typically done by CNC milling, which is a computer-controlled process that produces precise and repeatable results. Alternatively, 3D printing technology can also be used. Quality control. After the impeller is manufactured, quality control is required to ensure that the impeller meets specifications. This can be done through visual inspection, measurements, and testing. Assembly. The Pelton runner is finally assembled into the hydroelectric power station, where it is connected to other components such as the generator and the control unit. It is important to note that the production of a small hydro Pelton runner is a complex task that requires specialized knowledge and experience. It is recommended that you consult an experienced fabricator or engineer for the planning and execution of this project. A Kaplan turbine is a type of hydroelectric turbine. Used in run-of-the-river power plants, it is named after its inventor, Austrian engineer Victor Kaplan. The Kaplan turbine has a propeller-like runner, with adjustable blades that allow for efficient operation over a wide range of water flow and head conditions. The global hydro company produces Kaplan turbine runners, including Kaplan runners for small hydro power plants and large hydroelectric power plants. The design process involves selecting the appropriate materials for the runner based on the site conditions and power requirements. The runner design also includes the shape and size of the blades, the hub, and the band that connects the blades to the hub. Once the design is complete, the runner is cast in a foundry using a high-strength, corrosion-resistant alloy such as stainless steel or bronze. The casting process involves pouring molten metal into a mold of the runner shape. After casting, the runner is machined to the final dimensions using precision tools. This includes cutting the blades to the correct shape and angle, and drilling holes for the band and hub. The blades are then assembled onto the hub using a band or other connecting mechanism. The assembly process requires careful alignment of the blades to ensure smooth operation and maximum efficiency. Finally, the completed Kaplan runner is tested to ensure it meets the performance specifications. For the particular hydroelectric power plant, this may include tests of the runner's efficiency, flow characteristics, and durability under varying operating conditions. We're American Hydro is a leading provider of high-performance hydro products and services for the hydropower industry, with over 130 years of experience. We're American Hydro has developed a reputation for excellence in engineering, manufacturing, and service. Their product portfolio includes a wide range of equipment for hydroelectric power generation, including turbine runners, wicket gates, bearings, and shafts. They also offer specialized engineering services for hydropower projects, including design, modeling, and analysis. We're American Hydro is committed to providing sustainable solutions for the hydropower industry. They offer a variety of services to help customers optimize the performance and efficiency of their hydroelectric power plants, including performance testing, equipment upgrades, and maintenance services. In addition to their product and service offerings, We're American Hydro is also committed to providing exceptional customer service. They work closely with their customers to understand their unique needs and develop customized solutions to meet those needs. Overall, We're American Hydro is a trusted partner for the hydropower industry, offering high-quality products, services, and expertise to help customers achieve their goals and maximize the performance of their hydroelectric power plants. VAG Armaturen GmbH is a German company that manufactures valves for the water and wastewater industry. One of its products are contactor and control valves suitable for use in hydroelectric power stations such as the Sloy hydroelectric station. At the Sloy hydroelectric power station in Scotland, VAG control valves are used to control the water flow in the turbines. These fittings consist of a valve body, a control cone or disc assembly, an actuator system, and various sensors that monitor and control the condition of the valve. VAG control valves enable precise control of water flow, resulting in improved turbine performance and higher energy yield. In addition, the VAG fittings are characterized by their robust construction and high reliability, which is particularly important in a critical application such as hydropower. VAG Valves GmbH is a German company that manufactures valves for the water and wastewater industry. One of its products is control valves, which are suitable for use in hydropower plants such as the Sloy hydropower station. At the Slough hydropower station in Scotland, VAG control valves are used to control the water flow into the turbines. These valves consist of a valve body, a control cone or disc assembly, a drive system, and various sensors that monitor and control the valve's condition. The VAG control valves allow for precise control of the water flow, resulting in improved turbine performance and higher energy output. Additionally, VAG valves are known for their robust construction and high reliability, which is critical in a critical application such as hydropower. The fabrication and assembly of an 8.5 megawatts Francis turbine at EBCO Industries would involve several steps, including design, fabrication, machining, assembly, testing, and installation. Here is a general overview of each step. The first step in the fabrication of a Francis turbine would be to design it according to the specific requirements of the project. This would involve determining the size, shape, and configuration of the turbine components, including the runner, stay vanes, wicket gates, and draft tube. Once the design is finalized, the next step would be to fabricate the various components of the turbine. This would involve cutting, shaping, and welding the metal parts according to the design specifications. After the fabrication process, the components would be machined to ensure they are the correct size and shape. This would involve using precision tools such as lathes, milling machines, and grinders to remove any excess material and create a smooth finish. The components would then be assembled together to form the complete turbine. This would involve fitting the runner, stay vanes, and wicket gates together and connecting them to the shaft. Once the turbine is assembled, It would be tested to ensure that it meets the required performance specifications. This would involve running the turbine under different operating conditions to measure its power output, efficiency, and other parameters. After the turbine has been tested and approved, it would be installed at the project site. This would involve transporting the turbine to the installation site and then mounting it in place. Throughout the entire fabrication and assembly process, quality control would be a top priority to ensure that the turbine meets the highest standards of safety and reliability.